Okay, hi Mr. Kwong. This is my third video for the third problem. So the problem says that you have to create a sinusoidal inequality from this. Determine the exact values of x that satisfy the inequality. Your solution must include the CAST rule and angle radian measurements. Only limit your domain to a function for exactly 2 cycles of the function. So first things first, we of course have the corresponding letters with our student number. We have to sub those into this. So it's going to be 2, 1, sine bracket pi over b, which is going to be 5 bracket x minus 4 greater than or equal to -1. So bring that to the other side. It's going to be 2, 1, 2, 1 sine 2, 1 sine bracket pi over 5 x minus 4 plus 1 greater than or equal to 0. Okay, so now what we have to do first is determine the period. So what is the period? Period is equivalent to 2 pi over b. In our case, our b is pi over 5. So our period, therefore, has to be 2 pi over pi over 5. So our period actually equals to 10 radians. 10 radians. So now times that by 2 because you want to find 2 periods. So therefore the 2 periods is equivalent to 20 radians. Okay, so now that we found the period, we can write the domain. Our domain is going to be that 0 greater than or equal to x, but x cannot be greater than but can be equal to 20. That is our domain. Now, what we have to do is now try to find the x-intercepts. So, finding the x-intercepts now, we have to, first of all, figure out if sine is positive or negative. So again, write this entire thing out. 2 sine bracket pi over 5 bracket x minus 4 greater than or equal to, bracket plus 1 greater than or equal to 0. So what we first have to do now is, of course, bring the 2 over and the sign. So it's going to be pi over 5 bracket x minus 4 is going to be, this shouldn't be greater than or equal to, plus 1 is equivalent to 0. So what that's going to become now is this is going to be equal to minus 1 pi over 6. So what does that mean? That means that sine is actually indeed negative, because if you were bringing to 1 over, it would be minus 1. And then 2 it'll be negative 1 over 2, bring the sign over, and therefore sine is negative. So what does that mean? That means that sine can only be in quadrants here and quadrants here. Quadrants 3 and quadrants 4. This is the only other quadrants where sine is negative. And the angles in here should be pi over 6. And as well here, pi over 6. Okay, so now let me erase this off the board, create some space. So now we know that the angles are pi over 6. Now let's solve for quadrant 3 first. Quadrant 3. So in quadrant 3, it's going to look something like this. Pi over 6. And to find it, we're basically going to have to write, it's going to be something like pi over 5. Pi over 5 bracket x minus 4 is going to be equal to pi over 6 plus pi. And what we're going to get is at the end x minus 4 is equivalent to 35 over 6, so therefore x is equivalent to 59 over 6. Now, this is one answer. Because we want to find it in 2 periods, we can actually add a 10 to this. So another answer for x is also going to be plus 10. So another answer is as well going to be 119 over 6. 119 over 6. So now let's move those answers to the side. Let me create some room for that. So let's move the answers over here. Let's get rid of some things. Let's keep the domain. And let's write the answers for x that we have so far. So we have one answer is that x is equivalent to 59 over 6, and the other one is x is equivalent to 119 over 6. And now we gotta have to solve this for quadrant 4. So in quadrant 4, it's gonna look something like this. Pi over 6. And the equation is gonna be something like pi over 5 bracket x minus 4 is going to be equal to 2 pi minus pi over 6. So what you're going to get is x minus x minus 4 is going to be equal to 55 over 6. Bring the 4 over. X is equivalent to 79 over 6. So now, if we were to add a period to this, we would actually go over our domain. So the only way to find another value for x was actually to take away a period. So the other answer is going to be 19 over 6. So this is again another x. X is equal to 79 over 6, and the other x is going to be 19 over 6. Now, what we have to do is to be able to find which sections of the sinusoidal function we're actually interested in, which satisfy our inequality that has to be greater than or equal to 0. I've written these backwards. I've just realized that we should write it like this. Greater than or equal to 0 is that we need to use the number line strategy to find out which sections of the sinusoidal function we are actually looking for. So what we're going to do is, of course, use the equation 2 sine bracket pi over 5 bracket x minus 4 bracket and then bigger bracket, and our bigger bracket plus 1 greater than or equal to 0. So now we draw our number line, and the points we're going to put on it, of course, 0. Our first x-intercept, which is 19 over 6. So over here we're going to put 19 over 6. The next x-intercept, which is going to be 56 over 6. So 56, or 59 I should say, sorry, not 56. 59 over 6. The next x-intercept, which is going to be 79 over 6. And our final x-intercept, which is 119 over 6. And then over here is going to be 20. So now to determine each section if it is positive or negative, we have to select just a number between 0 and, for example, 19 over 6. Plug that into this formula, and if it is indeed the number that we get a negative or a positive, we write that on our graph. So for example here, if we take 12 over 6, so let's just choose 12 over 6, or 2, and you plug that into here, so this is going to be sine bracket pi over 5 bracket 2 minus 4 bigger bracket plus 1 is equivalent to 0. Actually, it's not equal to anything. And if we actually do this, we figure out that it's going to be negative 0.90211. So because it's a negative number, this therefore here is a negative. So let me erase this now. Let me erase that, and let me make this a little bit better. So here is going to be a negative. So now we got to pick a number between 19 over 6 and 56. The number I would like to choose was 60 sorry, not 60. My apologies, 24 over 6. So if you do 24 over 6, it's actually just 4. So if you plug in 4 into this, 2 sine bracket pi over 5, 4 minus 4 bracket plus 1, what we would get is 1. You just get the number 1. So because 1 is positive, then therefore this section of the graph is positive. Now, the next part is 56 over 6 to 79 over 6. Now for that, the number I chose was actually 60 over 6. So that's just 10. So therefore 2 sine bracket pi over 5, 10 minus 4 bracket plus 1. What you would get if you were to solve this was negative 0.1756. So because again it's negative, this section of the graph is negative. And again, erase this. Now look at the next section of the graph, which is 79 over 6 to 119. And 119, the number I would like to choose was 90 over 6 or 15. So this is going to be, again, plug it into the equation. 2 sine bracket pi over 5, 15 minus 4 plus 1. So if you were to actually solve this, this would be a positive number. It would be 2.176, showing that this part of the graph as well is a positive. So now we move on to the final part of the graph. The final part of the graph is 119 over 6 to 20, and the number I chose for that was 120 over 6 or 20. So it's going to be 2 sine bracket pi over 5, 20 minus 4 plus 1. And if you were to solve this, you would get negative 0.176. And because it's negative, then therefore this area as well is negative. So now we have to write our final statement. So the final statement is going to be, therefore, the inequality which we chose, which was 2 sine bracket pi over 5 bracket x minus 4 bracket plus 1 greater than or equal to 0. Oh, I wrote it backwards once again. It is this way actually. Greater than or equal to 0, greater than or equal to 0. In the period of, so in the period that we had, in the period of 0 greater than or equal to x greater than or equal to 20, the times that inequality is indeed satisfied is at 19 over 6 to all the way up to 59 over 6, and it's going to be 79 over 6 as well as 119 over 6. So during these two sections of the graph, as we can see, they're positive. The inequality is satisfied. Thank you so much, Mr. Kwong. I hope that video was well done, and I will see you later.